I'm Anil Kumar. Welcome to my series on calculus. I'm discussing with you questions from previous test paper on related rates. We have 8 questions to discuss in this particular video, and I hope that will prepare you well for this unit. You can always pause the video, copy these questions, work them out, and then look into my suggestions. So you can see the first 4 questions now. Here are the other 4 questions of this test paper. Right, so we'll now take them one by one. Question number 1. The side of a square is increasing at the rate of 3 centimeters per second. At what rate is the area increasing when the side length is 5 centimeters? So let us say we have a square. So we'll just make a small sketch on the side. Write down what is given, right? What formulas are required, and then work out the details. So we are saying this is our square whose side lengths are s each. The side of a square is increasing at the rate of 3 centimeters per second. That means ds dt is 3 centimeters per second, right? At what rate is the area increasing when the side length is 5 centimeters? So we are given, let me write down given and then find. And what do we need to find? We need to find the rate of increase in area. So that is dA dt when side length is 5 centimeters, when s is equals to 5 centimeters. Correct. So that is the equation for us. Now let's write the relation between area and the side length. So area of a square is equal to side length square. Differentiate with respect to time. So we get dA dt is equals to 2 times s times ds dt. So we need to find area, change in area, when s is 5. So let's substitute these given values. So we have dA dt when s equals to 5. Substituting, we get 2 times 5 and ds dt is 3. So we get 3. Area is centimeter square per second. Correct? So we get our answer, which is 10 times 3 is 30 centimeters square per second. Clear? So that is how we are going to get the solutions to all our questions, right? If you want, you can write specifically the answer separately. So it will be 30 centimeters square per second. Correct? Now let's take the second question. A toy car moves along a straight line so that after t seconds its displacement from the origin in meters is s meters. Given that s of t is minus 2 t cube plus 6t square, t is between 0 to 5, determine an expression for velocity and acceleration at time t. Initial velocity and initial acceleration. The toy car's maximum velocity. When is the toy car moving towards its initial position? Correct? So in this case, what we are given? We are given the displacement, right? S of t as equals to minus 2 t cube plus 6t square, and that is under a boundary condition where time is between 0 to 5, both included. Now part A of this question is expression for velocity and acceleration at time t. So that is the derivative, right? So the velocity at any time t is the derivative d dt of s of t, correct? So which will be minus 6t square plus 12t, right? So that becomes the expression for velocity. B, initial velocity, and let's also find acceleration. So A will do acceleration as derivative of velocity. We can write this as v dash t, which is going to be minus 12t plus 12. Okay? So that becomes the expression for acceleration. Now part B is initial velocity and initial acceleration. When we say initial, that means time is 0, right? So it's just the starting point. So for part B, velocity initial, that means v0. Substitute 0 here, we get 0. The units are meters per second, right? So meters per second. And here, acceleration, initial acceleration. When I substitute 0 here, we get 12 meters per second square, correct? Part C is the toy car's maximum velocity. Now to find the maximum velocity, we need to check when is the velocity, when is the acceleration? 0, right? So it's a turning point, correct? So for part C, what we are going to do is we have to find when is acceleration 0. So we need to find the critical number. That means a of t should be equal to 0, right? So substituting that, if I write 0 equals to minus 12 t plus 12. So that really gives you that t is equal to 1, right? So 1 second. So at t equals to 1 second, we have a critical number. Now we need to verify whether at this critical number we have a maximum velocity or a minimum velocity, right? So that is what you need to check. Since you are also given a boundary condition, you can also check with the boundary condition in this particular case, right? There's only one critical number at this stage. So what we will do here is that we'll check the velocity at t equals to 1, 0 and 5. We already have an expression for velocity which is right there. So velocity at 0, we know is 0, right? Velocity at 1 is, substituting 1 here, we get minus 6 plus 12, which is equal to 6. And then let's check velocity at 5. At 5, it will be minus 6 times 5 square plus 12 times 5, correct? So which is, let's use the calculator. So 12 times 5 is 60. Take away 25 times 6. So that is negative 90, right? So that is the lowest velocity. So we have the maximum. So therefore, maximum velocity is at our critical number, which is t equals to 1 second, right? So the toy car's maximum velocity is how much? And this maximum velocity is 6 meters per second. Is that clear to you? So that is going to be our solution for this part. Now for part D, let's move on and do it on a fresh page. When is the toy car moving towards its initial position? Now how do you figure this out? Now, important thing to understand here is that the product of the displacement and the velocity, if it is less than 0, that means it is negative, then it is towards initial position. Is that clear to you, right? So that is the condition. So we are going to just test the product of displacement and velocity. So let's work it out. S of t is minus 2t cube plus 6t square. You could write this in factored form also. So if I take minus 2 common, in rather t square, minus 2t square common, so I get t minus 3. Right. So that becomes a factor. Now minus 2t and t minus 3. As far as the velocity is concerned, we just found derivative of this, so which is minus 6t square plus 12t, right? So we can take minus 6t common, so that gives us t minus 2. So the product S of t times v of t is what? Product of these two. So which we get as minus and minus becomes positive. 6 times 2 is 12. T times t square is tq. And here we get t minus 3 times t minus 2. So that is what we get. So we have critical numbers at 0, 3 and 2. So we can test in between these. That is one way of doing it. So let us do that testing. So we'll make a table of values to test. You could also use a graph to figure this solution. So here we have t as equal to 0, t as equal to 2 and t equals to 3. So let's take a test point on either side. So we are only worried about the right side. So test point could be 1, 2.5 and let's say 4. The factors are to be tested 12t cube, then we have t minus 3 and we have t minus 2. So when this is positive, 12t cube will be positive. T minus 3, that is going to be negative only after 4. Only positive after 4, right? So before that, it's going to be negative. T minus 2 will be negative for t equals to 1 and thereafter it is going to be positive. Now when you multiply these three, what do you get? You get two negatives means a positive, and here one negative means a negative, and that is also positive. Correct? Now it's a cubic function. Some of you could have drawn a graph also. Leading coefficient here is positive, so the graph will be going through these zeros, right? These are like zeros, correct? So we have a zero which is kind of like this. Is that okay? Now this is cubic, right? So this will be kind of like this. So that is how we have, and that is the interval where the product displacement and velocity is negative, and that is the time during which the object, toy car in this case, is moving towards the initial position, right? So we can now write down our answer, and our answer is that the toy car is moving towards initial position during interval which we can write as an inequality between 2 and 3 in seconds, right? So time is in seconds, time in seconds. Is that clear to you? So that is how this question can be answered. So I hope the concept is absolutely clear. Right? Question number 3. Air is being pumped into a spherical balloon at the rate of 7 pi centimeter cube per second, right? So let's say that is our spherical balloon, and air is being pumped at a rate of this. That means change in volume, right? So we have dV dt is given to us, which is 7 pi centimeter cube per second. Determine the rate of change in balloon's radius. That means we need to find dr dt when the volume of the air in the balloon is 36 pi centimeter cube. When the volume is equal to 36 pi. Now, we are not given the radius, we are given the volume. So in such cases, we need to figure out how much will be the radius for the given volume, correct? So that is one step. So in such cases, we need to find the radius. Now we know that the volume is 4 by 3 pi r cube. Now we can use this relation to get the answer. So let's use this relation. Volume is 36 pi. So for 36 pi, 4 by 3 pi r cube. So pi and pi cancel, and let's multiply this. We have 36 times 3 over 4 is r cube. So we get 9 times 3, which is 27, is r cube. So cube root of 27, which is 3, will become r, right? So r is equals to 3. Okay. So basically at this time we now have worked out that r is equals to 3 units. Now we can continue and then find the solution. Okay. So that is sometimes required. So once again we have volume as 4 by 3 pi r cube. Let's find the rate of change of volume with time. So we have dv dt equal to 4 by 3 pi times 3 r square dr dt. Simplifying, we can get dv dt as equal to 3 and 3 cancel, and we have 4 pi r square dr dt. We need to find dr dt when r is 3. Correct? We know dv dt is 7 pi. So let's substitute these values. dv dt is 7 pi equals to 4 pi. R is given to us as 3 square, and we need to find what is dr dt. Is that clear to you? So we substituted the values, which are r equals to 3. Correct? Now at that time dv dt we know is a constant 7 pi centimeter cube, and we are considering this to be a sphere of radius r units. So let's simplify this. So we get dr dt as equal to, let me write it here on this side, dr dt as equal to 7 pi over 4 pi times 9. Correct. So pi and pi cancel. So we get 7 over 36. So that is the rate, and the units will be centimeter per second. So the rate of change of balloon's radius, so we can write down now the answer, that the rate of change of balloon radius with time when the volume is 36 pi is equal to 7 over 36 centimeters per second. Clear? So that is how we are going to solve this. Let's move on and take the next question. Now let's take up question number 4. A 10-meter long industrial ladder is leaning against a wall on a building site. The top of the ladder starts moving down the wall at the rate of 0.5 meters per second. Determine how fast is the foot of the ladder moving along the ground when it is 6 meters from the wall. So let's make a small sketch here. Let's say that is the wall, and this is the ground. Ladder 10 meter long is kind of like this. Okay. So we're given this is 10. So 10 meter long is leaning against a wall. The top of the ladder is moving down. So this top is moving down, and the rate is 0.5 meters per second. So we can say dy dt is equals to minus 0.5 meters per second, since it is moving down. Determine how fast is the foot of the ladder. So that foot of the ladder is moving. So we need to find what is dx dt when it is 6 meters from the wall. When this x is equal to 6, right? That is what we need to figure out. So that is the question for us. Now, in this case, we are using that as y and x and fixed length of 10. So the relation which connects them is x square plus y square equals to 10 square. Okay, so that is the relation. We can find the derivative with respect to, differentiate with respect to time. So we get 2 times x dx dt plus 2 times y dy dt is equal to 0, since the derivative of a constant is 0. Now, when x is 6, at that time, what is y? So we should also figure this out. So we'll do, when x is 6, we can write y is equal to 10 square minus 6 square root. When x is 6, right? So this is what the condition will be. So that gives you 100 minus 64 square root, right? So that is sorry, 64 is 36. Okay, sorry. So 100 minus 6 square is 36. And when you take away 36, we get 64 square root, which is 8, right? So we get this as 8. So y is 8 when x is 6. We can write here, when x is 6, y is equal to 8. We're going to need both the values of x and y, and that's why I made this change, correct? Okay. Now, you can always cancel 2 from these places. So what we get here is x times dx dt plus y times dy dt is equal to 0. Now, since we need to find dx dt, let's isolate this. So we have dx dt as equal to, taking this on this side, minus y over x dy dt. We know x, y, dy dt, and so we can always find dx dt where x is equal to 6. So that gives you y value is 8, x value is 6, dy dt is minus 0.5 or half, correct? So this can be calculated. So what we get here is half of this, which is 4 over 6 or 2 over 3. Correct? So half of 8 is 4, and 4 divided by 6 is 2 over 3, positive sign. And the units are going to be meters per second. Is that clear? So what we notice here is that we can write down our answer here, that the ladder slides at the rate of 2 over 3 meters per second. Perfect. So I hope the concept is absolutely clear. We'll take a short break here, and in part 2, we'll solve the rest of the questions. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.